Okay, so we are still in 7.1, factoring by GCF, so factoring out the greatest common factor in a polynomial, and then we left off right before factoring by grouping, so that's what this video will be on. Let me get down there. So the last example that we ended on, or the you try, was being able to identify a common binomial factor that you were then able to factor out or pull out of the polynomial. So I can factor out 2x plus 3, and then I think, okay, well, what times 2x plus 3 would give me the product 7x times 2x plus 3, and that would be 7x. And then I think, okay, well, what times 2x plus 3 would give me 2x plus 3, and that would just be plus positive 1. So we have factored this given polynomial, meaning we've rewritten the polynomial as a product. And we're going to continue doing that with our next method of factoring, which we call factoring by grouping, and you'll see why it's called by grouping in a second. So anytime you see a polynomial has 4 terms, it's actually any even number of terms, but we're not going to get too crazy. So if you see that a polynomial has 4 terms, you might want to try factoring by grouping, meaning that you can separate those 4 terms into 2 different groups and then factor the greatest common factor from each of the groups. So this first example, notice this is a cubic polynomial, polynomial that has 4 terms. So by the associative property of addition, I can group these first 2 terms together, and then I can group these second 2 terms together. Okay, remember the associative property of addition says that if we have a plus b plus c, that's going to be equivalent to a plus b, the quantity a plus b, and then plus c, which is also equivalent to a plus the quantity b plus c, where we can reassociate those terms. So all I've done is group the first 2 terms in this polynomial together and the second 2 terms. So now I want to look at this first grouping and think about what the greatest common factor of 12x cubed and 9x squared is. And that's going to be 3x squared. So I'm going to factor out a 3x squared from that first grouping. And then I think, okay, well, what times 3x squared would give me 12x cubed? That would be 4x. And what times 3x squared would give me negative 9x squared? That would be negative 3. Remember, you could always check that you have factored correctly by thinking about multiplying the polynomial back out, distributing this 3x squared back in. Okay, so looking at the second grouping of terms, the greatest common factor of 20x and 15 is going to be positive 5. So I can factor out a positive 5 from 20x and 20x minus 15. And I think, okay, well, what times 5 would give me 20x? And that's going to be 4x. And then I think what times 5 would give me negative 15, and that would be minus 3. Well, what do you know? We now have a common binomial factor that we can factor out. So I'm going to factor the 4x minus 3 out front. I'm going to pull that out front. And then I think, okay, well, what times 4x minus 3 would give me 3x squared times the quantity 4x minus 3, and that would be 3x squared. And then we think, okay, well, what times 4x minus 3 would give me the product 5 times 4x minus 3, and that would be plus 5. So we have factored that polynomial by grouping. meaning we have rewritten the polynomial as a product. All right. Now, all of the ones, not all polynomials can be factored by grouping. So not all polynomials with 4 terms or an even number of terms can be factored by grouping, but you can try. These examples are going to work factoring by grouping because I want you guys to get practice with this skill. Now notice that this is actually a quadratic polynomial that is not simplified. Notice that the negative 15x and 2x can actually be combined. Those are like terms. However, for practicing factoring by grouping, we are going to leave them separate. Now, we are going to next in 7.2 be factoring quadratic trinomials. And some teachers, a method of factoring quadratic trinomials is to separate the middle term and then factor by grouping. I prefer, myself and I believe that other teachers at Pinewood prefer to use the guess and check method, but this is one method where you would separate that middle term. Anyways, back to factoring by grouping. I'm going to try grouping these first 2 terms together, and then I'm going to group these second 2 terms together. So I think, what is the greatest common factor of the first grouping? And that would be 5x. And then I think, okay, well, what times 5x would give me 5x squared? That's going to be x. What times 5x would give me minus 15x? That would be minus 3. Okay, then I look at the next grouping, and the GCF of 2x and 6 is going to be 2. And 2 times x minus 3 would give me 2x minus 6. So now that I have my common binomial factor, I can factor out the x minus 3, and then the remaining factor will be 5x plus 2. And you could always check by multiplying the product back out. Okay, so we have a you try. I'll leave that for you to try. Okay, so this is a little bit different. It doesn't look different, but it's a little bit different. Notice that we have a minus. Subtraction is happening between the 2 middle terms. So in the other examples, we've had addition happening between the middle terms, the 2 middle terms. So then we had addition happening between the groupings. You need to be careful whenever there's subtraction happening between the middle terms so that you don't run into a sign error. So to not run into a sign error, I'm going to first rewrite this polynomial 6x to the 4th minus 24x cubed plus a negative 5x, right? That's the same as minus 5x plus 20. Okay, once I've done that step, now I'm ready to group and factor out the GCF. So the GCF of 6x to the 4th and minus 24x cubed would be 6x cubed. Okay, and x times 6x cubed would give me 6x to the 4th. Minus 4 times 6x cubed would give me minus 24x cubed. And the GCF of 5x, negative 5x and 20 is going to be 5. And when I think about what times 5 would give me negative 5x, that would be negative x. And then what times 5 would give me 20? Well, that would be minus 4. No, that would be plus 4, positive 4. Okay? Now, notice that these are not common binomial factors yet. They're slightly different. This is x minus 4. This is negative x plus 4. So the signs are different on the terms of the second grouping. So I'm actually going to factor out a negative 1 from this second grouping. so that I have minus 5 times x minus 4. When I factor the negative 1 out, it'll change the signs of that grouping. Make a little note there. Factor out negative 1. Now I have my common binomial factor. Let's go back to blue. So I can factor out x minus 4, and then that remaining factor is 6x cubed minus 5. Now, at this step, going from here to here, I could have just factored out negative 5. And that would have been one less step. And I could have recognized I was trying to get an x minus 4 as my common binomial factor. And you guys will be able to see that with practice. Okay, so here's our tip. So typically, if a leading coefficient is negative, you're usually going to want to factor that out. Okay, so again, we have subtraction happening between the two middle terms. So before I can group, I'm going to rewrite the polynomial. Okay, now I am ready to group. I don't want to show it on this video, but if you are curious how you could run into that sign error, I'm happy to show you in person. All right, GCF of that first grouping will be 3y squared. So 3y squared times y squared plus 3 would give us 3y to the 4th plus 9y squared. And then I'm going to factor out a negative 6 from the second grouping. So I'll have y cubed plus 3. And voila, we have our common binomial factor that we can now factor out. Now notice that this factor here actually has a GCF other than 1. It has a GCF of 3. So we could actually factor that 3 out. And then by the commutative property multiplication, I can pull that constant, that 3, out front of the product because it just looks nicer. Now, we had that happen. We ended up having a GCF of 3 at that step because if you look at the original polynomial, you'll see that the coefficients actually have a GCF of 3, a GCF other than 1. So you can always check for a GCF before you try other factoring methods. So you could look at the coefficients or look at all the terms to see if there's anything that you can factor out first before using factoring by grouping, or in 7.2 you'll see factoring by guess and check, organized guess and check. Okay, it can be helpful for us to recognize opposite binomials. So notice that 5 minus x is not the same as x minus 5, even though they look very similar. 5 minus x can be written as negative 1 times x minus 5. So just factoring a negative 1 out, and then we would have a factor of x minus 5. So that can be helpful. So I'm thinking that will be helpful in this example. Notice that we have addition happening between the two middle terms, so we can group. Now this polynomial is not written in standard form. Notice that the constant and minus 2x are kind of flip-flopped. That's okay. I have this written in the order that it will work for factoring by grouping. So we'll just leave it for now. Okay, so factoring out the GCF of the first grouping, 3x squared, then we'll have x minus 5 as our factor. And then I can factor out a 2. So I would have 5 minus x, which, like the previous example we saw, x minus 5 is not equal to 5 minus x. So we can actually factor out a -1. They look very similar, but they are not the same. So when we factor out a -1, that'll become minus 2 times x minus 5. It changes the signs of the terms inside the parentheses there. And then now we have our common binomial factor. We can factor out the x minus 5. How many of these do we have? Oh, last one. Okay. So again, addition is happening between the two middle terms. So go straight to grouping. GCF of that first grouping is 5x squared. GCF of the second grouping is 4. Okay. Now we can either factor a -1 out of the first, out of 3 minus 2x, or we could factor a -1 out of 2x minus 3. I'm thinking I'm just going to factor a -1 out of the first grouping. Why not? Doesn't matter. So that's -5x to the 5th squared. So then we'll have 2x minus 3 plus 4 times 2x minus 3. Now we have our common binomial factor. Now you guys will see, it doesn't matter. This is fine. This polynomial is in factored form, but I really don't like having a negative leading coefficient on a factor. So I'm actually going to factor a -1 out of this second factor here and pull the negative out front so that I have, it's like -1, but you don't have to write the 1, times 2x minus 3 times 5x squared minus 4. And we will finish there. Okay. Remember, we are going to be using this skill of factoring very soon when we're working with quadratics.